Welcome to Copernicus AI, Frontiers of Science. I'm Matilda, and today we're exploring how recent advances in understanding concepts through category theory are revolutionizing cognitive science. Adam, what makes this research so potentially revolutionary?
Thanks, Matilda. It's about how we understand understanding itself. For decades, cognitive scientists have debated how we represent concepts in our minds. Now, research is pointing towards a fascinating possibility that concepts are fundamentally vectors. As Steven Piantadosi and colleagues outline in their recent paper, Why Concepts Are Probably Vectors, published on PubMed, we'll link to it in the description. This vector representation allows for the computation of various properties like similarities, features, and relationships.
So, instead of thinking of a concept like apple as a static definition, we're seeing it as a dynamic point in a multidimensional space?
Exactly. Think of it like this. Each dimension represents a different attribute: color, taste, texture, use. An apple occupies a specific location in that space, defined by its values along those dimensions. This allows us to easily calculate how similar or different it is to other concepts, like orange or car.
That's a significant departure from traditional symbolic AI, which relies on discrete symbols and rules. How does this vector-based approach address some of the limitations of symbolic AI?
Symbolic AI struggles with ambiguity and nuance. Vector-based representations, on the other hand, allow for graded similarity and contextual sensitivity. For instance, Piantadosi's work suggests that vector representations can support compositional generalizations and relational inferences, things that are notoriously difficult for symbolic systems.
Are there other areas of cognitive science where this vector-based approach is gaining traction?
Absolutely. The idea that our minds use something akin to vector spaces to represent information is also supported by research into inductive reasoning. As Hayes and Evan Heit explore in their 2018 paper, Inductive Reasoning 2.0, also available on PubMed, inductive reasoning involves using existing knowledge to make predictions about novel cases. The structured statistical approach they discuss aligns well with the idea of concepts as vectors within a structured space.
So we're not just talking about individual concepts, but also the relationships between them being encoded in this vector space?
Precisely. And this is where category theory comes in. It provides a mathematical framework for describing these relationships and transformations between different conceptual spaces. It's like having a universal grammar for thought.
This sounds incredibly abstract. What are some of the practical implications of understanding concepts as vectors?
One potential application is in improving machine learning algorithms. By using vector-based representations and category theory, we can create AI systems that are better at understanding and reasoning about the world. For example, they could be better at generalizing from limited data or at understanding analogies.
Could this also have implications for understanding and treating cognitive disorders?
It's certainly possible. As explored in Friedman, Turk, and Budson's paper, The Current of Consciousness, Neural Correlates and Clinical Aspects, understanding how neural circuits represent and manipulate information is crucial for understanding consciousness and cognitive disorders. If concepts are indeed encoded as vectors in the brain, then disruptions to these vector representations could potentially underlie certain cognitive deficits. We'll link to that paper in the description.
Are there any limitations to this vector-based approach?
Of course. One challenge is understanding how these vector representations are actually implemented in the brain. We also need to develop more sophisticated models that can capture the full complexity of human thought. Plus, as Hayes and Heit point out, more research is needed on the structured statistical approach to induction.
Adam, this has been a fascinating exploration of how category theory and vector-based representations are changing our understanding of cognition. Any final thoughts?
It's an exciting time for cognitive science. By combining insights from mathematics, computer science, and neuroscience, we're starting to unlock the secrets of the human mind. And vectorizing our thoughts is a big step in that direction.